We want to talk about galvanometer conversion, that is converting galvanometer to another device. But quickly, let us revisit what we have said to exercise our knowledge of what we are learning to better understand galvanometer conversion. We said that if you have, for example, resistors connected in series, these two resistors are connected in series, maybe a current is entering into these two resistors. We said that it is the same current that will flow through these two resistors. Same current, this current will enter into this resistor to be 2 ohms, and it will also be 2 ampere rather, 2 ampere, good, because they are in series. But when we are talking about potential difference across the resistor, there will be potential difference drop at R1 and at R2. The potential difference at R1 will be different from the potential difference across R2. But we say if you have a branch out connection, a parallel connection, such as this, R1 and R2. Now the same potential R1 and R2, they will be at the same potential. The potential difference across R1 will be the same as the potential difference at R2 because they are in parallel connection. But there will be current drop in R1 and R2. That is, the current passing through R1 will be different from the current passing through R2. It will be different from the current passing through R2. Now, let's exercise more on this knowledge. Let's get better understanding. Now, if you have this three resistor 2 ohms, now that is a setup of a circuit where you have three resistors connected in parallel, and you have with a cell of 12 volts. Imagine that this 12 volts is just has no what internal resistance. So the potential difference or terminal potential difference across this in this circuit is 12 volts. That we are just neglecting the internal what resistance. So this 12 volts is what we are the potential difference we are actually taking from the cell. Now you have this 12 volts with these three resistors. Now this is a setup. You can set this up. Now the question you ask, what currents will now be flowing in this whole circuit? What current can you be flowing? One way you can do it setup is just to convert your ammeter, which is your device for measuring current. Another way of doing it is using calculation. Using Ohm's law. We have Ohm's law saying that V is equals to I R. I is now equals to V over R. So to calculate the current flowing through this circuit, you say I is equals to V over R. Where this R will now be the equivalent resistance of these three resistors. So if you set up a cell with resistor, with this Ohm's law, you can be able to find what current flowing through these circuits. Now, but that is in setup. But if you are giving this now, you set it up, you can use questions can be asked. Questions can be asked. One of the questions that can be asked is like what we have just said. Let's say, given this cell, given this supply rate potential difference of 12 volts across this circuit with this three resistors, what is the current across the circuit? So one question that can be asked: current across the circuits. Current across the circuits. And you can cover this part. You are given these three resistors and this voltage. So what is the current across the circuit? Which you can use this to solve. Now, another question that can arise, someone will say, because these three resistors are in parallel, we have said that though this example is the current across the circuit and will flow through across the circuit, what is the current drop at each resistor? Because the current that will enter into this resistor will not be the same with this one and this one. So another question that can be asked is what is the current across each resistor? Because they are all in parallel. Currents across each resistor. Now, the third question that can be asked is, you already know the setup. Is this voltage with this resistor that provided this current across this resistor? So they can ask you what potential difference with this resistor can give us this current. you already know your setup, but the question is, what amount of voltage or what amount of potential difference across this circuit with this resistor will be able to give us this current? So they can ask you what would be the word voltage across the word cell, or the potential difference, the terminal potential difference, because we are ignoring internal resistance. Now, so the third question is, what's potential difference across the terminal of the cell with resistors can give a certain amount of current. So you are setting up, you know the potential difference across the cell. But in the question, you can say, let's assume you don't know what potential difference with this resistor can give us this current. Can be asked to find this. Now let's quickly recap what we have said. These are some of the questions that can be asked. One is current across the circuit. You have this cell supplying this terminal potential difference with this resistor. What will not be current flowing through across the resistor? Now we said we can use this formula. Let's quickly do it. One. You say I is equal to voltage over equivalent resistance. So we find ROE. ROE, since these resistors are in parallel, to get the equivalent resistance, you say 1 over ROE equals to 1 over 2 plus 1 over 3 plus 1 over 4. And if you take the LCM, it is 12. 6 plus 2, 6 plus 4 plus 3, which should give us 13 over 12, 1 over ROA. Now ROE will be equal to 12 over 13 ohms. 12 over 13 ohms. To the LCM of 2, 3 and 4, which gives us 12. 2 divided 12 is 6. 6 divided 12 is 4. 4 times 1, 4. 4 divided 12 is 3. 3 times 1 is 3. 6 plus 4 plus 3 is 13. They will take the reciprocal of both sides. So, if you want to calculate the current across this resistance, the first thing you must do is to calculate the equivalence resistance from the number of resistors you have. Once you are done, you now use this Ohm's law. I is equals to V over ROA. Our V was 12 volts. Divide our ROE is 12 over 13. Now I is equals to 12 times 13 over 12. We should have 13 ampere, which is what is here. That is how we arrive at 13 ampere. So you have calculated the current across each resistor. So that's how to do that. If you are giving the terminal potential difference of the cell and with resistors, you can see what is the current across the resistor. You use this Ohm's law formula. But this ROE will not be the equivalent resistance of the resistor. And the V will not be the terminal potential difference across the cell. Now the second question will be current across each resistor. Current across each resistor. Now you know the terminal potential difference, you know the current across the resistor. But what should be the current in each resistor? Because they are in series connection. They are in what? Series connection. Now to find the current across this resistor, you still have to engage Ohm's law. I is equals to V over R, but it should not be the equivalence resistance. It should not be resistance of that resistor. You are looking for the current at it. For example, if you are looking at the current at this resistor, R1, R2, R3, you are looking for current flowing through R1. You are looking for current flowing through R1. You say I is equals to, now our potential difference across the terminal of the cell is 12, and the resistance of the resistor at R1 is what? 2. So your V is this, Why your resistance should be this? So it will be 12 divided by 2 should give us 6 ampere. But if you are looking at current flowing through RO2, current flowing through RO2, current flowing through RO2, it will still be I is equals to V over RO. But our V will still be 12 volts. Because we are looking at RO2, we are taking resistance here, which should be theory. So 12 divided by 3 is what? 4 ampere. So the current flowing through this second resistor of resistance 3 ohms is 4 ampere. Now, the current flowing through RO2, you still use engage Ohm's law. I is equals to V over R. Where V is the terminal potential difference or the potential difference across the cell, ignoring the what? Internal what? Resistance, which is 12 volts. Now, because we are looking at the current that is flowing through RO2, we are looking at the resistance at RO2, which is 4 ohms. So 12 divided 4 is what? 3 ampere. So the current flowing through this resistor RO1 is 6. Current flowing through this second resistor is 4, and current flowing through this third resistor is 3. Now, you can quickly cross-check what we have just done to look whether they align. Current flowing through RO1 is 6, through RO2 is 4, through RO2 is 3 ampere. If you add everything together, the total current is 6 plus 4 plus 3. 6 plus 4 plus 3 is what? 13 ampere. That is to show that the current flowing out of the battery toward the battery, the full circuit is 13 ampere. But it's not 13 ampere that is flowing through this one. There's a current drop here, current drop here, current drop here. But if you add everything, you have your 13 ampere flowing through the total circuit. Now, the third question that we say that can be asked is what potential difference across the terminal of the cell when the resistors can give a certain current amount of current. That is to say, don't just imagine that we don't know this terminal words, the potential difference coming from this cell that will give us this current with this resistor. What would not be the current? What would be the potential difference of these terminal across the terminals of this cell? What would be the what? Potential difference of the terminals of the cell through this resistor that will give us that current. What will be the potential difference? What will be the potential difference? 12. But it can be asked. So how do you get that balance? We still use Ohm's law. Ohm's law. Ohm's law. So we are looking for the top and we are looking for this 12. We have to go about it from Ohm's law. We know that V is equals to I R. So we are looking for this V. But the arrow to that our V, the arrow we are using is the equivalent resistance. The equivalent resistance. The equivalent resistance. And from the last part, we got equivalent resistance to be what? Equivalent resistance to be 12 over 13. 12 over 13 ohms. Now, our current that is flowing across the whole circuit, that will not be I. The current that is flowing across the whole circuit is 13 ampere. Is what? 13 ampere. So just plug it into this formula. This is equal to I ROE. So now the I is what? 13 times ROE is what? 12 over 13. 13 we strike at 13. You are left with 12 ampere. So you need, you are left with 12 volts. So you need 12 volts, 12 voltage across this resistor that will give us 13 ampere. So somebody can quickly cover this part and ask you what is that. So that's how to go about it. These are some of the questions, especially this theory, that they can ask about parallel connection.
What voltage coming from the cell will give us this current when connected to this certain amount of resistor? That's one question. Another question is, what is the current that will flow across the resistor when you have this cell, this potential difference across this terminal with these resistors? we just discussed, what will not be the individual current flowing through this resistor? Because we say when resistors are in parallel, not the current flowing through this resistor is not the same. There's a current drop. So there's a way we will show you how to do whatever to calculate that. With this that we have done, we have exercised our knowledge discussing about Galvanometer conversion in short multiplier will make it more easier. So let's proceed.